power of logic. So starting from today, I'm going to start to go through the 2023 Aime Ii full solutions. So let's go on to number 1. The numbers of apples growing on each of 6 apple trees forms an arithmetic sequence where the greatest number of apples growing on any of the 6 trees is double the least number of apples growing on any of the 6 trees. The total number of apples growing on all 6 trees is 900. Find the greatest number of apples growing on any of the 6 trees. Okay, so now, just for sake of simplicity, if we actually let a number a to be the middle of these, and let 2d be the common difference between any two terms, and let a be the middle number, or like the arithmetic mean of all the 6 numbers. Then the 6 terms are basically a plus 5d, a plus 3d, a plus d, a minus d, a minus 3d, a minus 5d. Oopsies, this should actually be in the next line, but you probably get the idea. So now if we actually have all these to be the terms, then let's just look at the other condition, which is that the greatest number of apples growing on any of the 6 trees is double the least number of apples growing on any of the 6 trees. And because we just assume that it's actually monotonically increasing, so therefore we do not have to care about what d is equal to when d is like less than 0. So now, we also know that the total number of apples growing is 990, so we just add all of them up. We get, well, because 5d, 3d, and d all cancels with negative d, negative 3d, and negative 5d, we're remaining with 6a being equal to 990, so this gives that a is equal to 165, if I didn't make any mistake. Now I'll continue. Because the greatest number, the least number of apples is going to be a minus 5d, and the greatest number is going to be a plus 5d. So we simply just going to have a plus 5d equal to 2 times a minus 5d. Plus 5d equals to 2a. A plus 5d is equal to 2a minus 5d. And a plus 5d is equal to 2a minus 10d. A is equal to 15d. So this gives that d is equal to 165 over 15, which is just 11. And now, because we have the value of d and we want to find the greatest number of apples growing on any of the 6 trees, this is just going to be a plus 5d, right? The greatest number of apples on any of the trees is a plus 5d, which is 165 plus 5 times 11, which is going to be equal to 220, and that is finally our answer to this problem. Now let's go on to number 2. Number 2 says that recall that a palindrome is a number that reads the same forward and backward. Find the greatest integer less than 1000 that is a palindrome, both when written in base 10 and when written in base 8, such as 292 is equal to 444, but represented in base 8. Okay, so now, for any of the positive integers, because we know that the maximum exponent that is less than 1000 for 8 is going to be 8 to the cube, which is 512. So we know that the maximum case is going to be is when the base 8 representation is a 4-digit number. Because a cube is 112 and a to the 4th is going to be equal to 4,096, which is way larger than 1,000. So we know that the maximum is going to be a 4-digit number. So a 4-digit number then it must be represented as ABBA base 8, which A and B are just numerical digit from 1 to 9, and A cannot be 0, but B can possibly be 0. Which this one is just gonna be 512A plus 64B. Just write it in more formal way. A cubed A plus A squared B plus 8B plus A, which is equal to 513A plus 72B. Okay. So we have a claim here. Any 4-digit base 8 palindrome can be expressed as 513A plus B 772B, which A is greater than 0. So any of these in this form is going to have a palindromic or a symmetric base 8 representation, and A must be greater than 0, obviously. Okay, so now how are we gonna continue with this problem? So because A is actually just gonna be, because A can only be 1, value of A is 1, because we know that 513 times 2 is going to be equal to 1026, which is greater than 1000. So the maximum is just going to be 1, and 1 is going to be the only possible choice of A. And now we're just going to look at how many possible values of B are there, and just check all of them. Even though there might be a lot, but we can see that 72, because 72 is also a pretty big number, and 1000 minus 513 is only 487, and that is less than 72 times 7. So by varying the value of B, we only need to try up to B is equal to 6. So you can see that there aren't like a lot of values to try, because there are only 0, 1, 2, 3, 4, and 5, and 0 is obvious because 513 is not gonna be a multiple of, no, it's not gonna be symmetrical in this representation. And we know that we do not have to care about A is equal to 0, since that will actually go down to the 3-digit number. And if we cannot find any 4-digit palindromes, then we're just gonna continue with 3 digits. Now 513 plus 72 is going to be equal to 585. Aha! We get pretty lucky that's a palindrome, but we do not know if that's the maximum palindrome. Since it's saying that we only find the greatest integer less than 1000, but 585 still has quite of a distance from 1000. So let's just continue with our attempt. What about 513 plus 72 times 2? Well, that is equal to 513 plus 144, which is equal to 605.57, but that is not a palindrome, since 7 is not equal to 6. And now 513 plus 72 times 3, that's equal to 513 plus 216, which is equal to 729, and that is still not a prime. Now 513 plus 72 times 4, is equal to 513 plus 288, which is equal to 801. Still not a palindrome. D plus 72 times 5, 13 plus 360, which is equal to 873. And that's still not a palindrome. What about the last one? 513 plus 72 times 6. Well, that is equal to 513 plus 432, which is equal to 945. Still not a palindrome. So now we can basically conclude the maximum such number is equal to 585. And that is indeed our answer to this problem. Thank you for watching, hope you enjoyed, and I'll see you in the next video. Peace out.